It's going to be a clear night tonight. Let's go out back and uncover the telescope and get ready to do some imaging. It's been a while, been a couple of days since we've had a clear night, and there's not going to be a moon. So that's going to be a bonus because it's pretty light polluted here in the city.
We're still a good hour and a half before it's dark enough.
We're going to be shooting the Cygnus region. Cygnus is the Swan constellation. It's basically the Crescent Nebula. Crescent Nebula is going to be very small up there. I'm going to be using a 135 millimeter lens, so it's pretty wide angle. But there's a lot of nice nebulosity out there. Everything's pretty much set up, still wired, still plugged in, still got power, still powered up actually. So what I'm going to do tonight is manipulate these knobs and get my polar alignment. Pretty beefy knobs right here. I actually wear gloves, rubber gloves, so I can get a good grip on them. It's kind of a push-pull. It is a push-pull. You tighten one side and you loosen the other side. Same with the other axis. Tighten that one, loosen it. Tighten this one. So it's actually a two-hand deal. Get two hands going. The same on the other side. You can get two hands going like that. Here's the telescope set up here. This is the little camera. This is the actual camera that I'm going to use, the actual telescope that I'm going to use, 135 millimeter focal length. Here's the camera, and this is the guide scope that I'm going to be using. Kind of unusual setup. I'm actually guiding longer than I'm imaging. This is a 360 millimeter scope, 135 millimeter imaging scope. And there's the camera, the guide camera, and that's the imaging camera. And you can see that's where it's going to cool down. You can see it's the fan is going to cool down here. I'm going to turn it on here in a second. Then we're gonna take the lens caps off. The dew heater. All these are dew heaters. I'm going to turn that on right now. I think we're already on. Yep. Let's see. So this is going to prevent dew from forming as the night progresses. Take off all the lens caps on everything. And then, well, you can see it's keeping warm. Take the lens caps off because that affects the balance. Ooh, let's see the weights there that are balancing everything here. And then extend this. Make sure that extend that because this is the dew heater strap here. The lens is right there, but I got to extend that because that affects the balance. So let's see. And then over here, we got a Rubbermaid tub, and that houses a laptop. And this is just covering the Rubbermaid tub because condensation forms on this, and then dew forms out here. If dew forms here, then it's going to have some condensation inside. And so to prevent that, I'm having the dew is going to form on this old. I use it as a tarp, but it was an old vinyl sign that I repurposed. And so there's the laptop. I don't know, it's looking pretty cloudy outside. Let's see. Gonna clear. See my antenna. It's my HF antenna, my ham radio antenna. It's 63 foot long. End-fed halfway is what they call it. And then back there you see a omnidirectional 2 meter antenna, 2 meter 440 UHF VHF antenna right there. And that's a UHF VHF antenna. You know that right there. That's it's a VHF antenna. It's called a Yagi. And that switch between those two antennas. And that one's permanently pointed to the peninsula towards Williamsburg. So I use that one to get to the repeater out to Williamsburg. So that's going northwest pointing northwest. And that far one is a omnidirectional antenna. Use that one to catch all the other repeaters down here on the south side. And we got a good old antenna, TV antenna right there, because I get all my TV off air and by streaming. Look at that, it's clearing up already. That's south, due south, right there. Yeah, I think we'll gonna uncover up and start to cool down the scope. Before it gets real dark, I'll do a little polar alignment, and then we'll be all set. It's time to cool down the scope. It's gonna take about I'm gonna give it about a half hour to cool the scope down, and to get down to negative 10 degrees Celsius. I think that's what we're going for. It's gonna be cool. Should be shouldn't have any problem getting to negative 10, and then I think it's gonna be out in the 60s, 60 degrees Fahrenheit tonight. But wow, you can see it's really getting starting to clear up. Still cloudy over there, back that way. We're can't see it. Yeah, there it is. Still pretty cloudy back that way, but you can see the holes. It's gonna clear up pretty nice. All right, you can see that's the software for the mount that controls the mount. Here's the guiding software. Ooh, starting to get buggy out here. And here's the imaging software. So I am going to start the cooler power. There's the temperature. Inside a couple hours ago it was at 32 degrees. So let's see here. Start cooling this guy down. See, I had it set to 0 degrees because it was in the summertime. Now it's cooler. Shouldn't have any problem getting to negative 10. And then right there, turned on the cooler. So now it's going to take got it set to take a half hour to cool. If you cool too fast, it's going to get condensation inside the camera between the telescope and the camera. There'll be a condensation if you cool too fast. So good half hour to get down to negative 10. Let's see here, and you can see, you might be able to hear. Yep, you can hear the cooler. All right. So we'll let that sit for a while. Lens cap's off already here. It's a little itty bitty lens right there. Might as well take this guy off. Set her down in here. And I'll take so even you maybe want to have even though I'm using this little scope here, why do I have all this set up? Well, it's all put together because it's kind of a pain to take things off and on and rebalance things. So rather than take things, I keep everything put together. So if I want to switch between scopes, I just change cameras. Just change cameras between the telescopes. If I want to shoot something really tight, really with 1200 millimeters of focal length, this bad boy, then I just swap this camera out, put it down here, put this camera, guide camera, either here or onto this camera. So the options are there. The idea is I don't have to mess with the counterbalance and weight and the setup so much. Just if anything, I just gotta slide the whole rig back and forth just a little bit, just because this does affect the balance. Just moving this camera to here to from there affects the balance. So getting dark, it's starting to get clear. Wow, look at that. All right. Yep, no problem. So we'll be gets dark here shortly, in maybe about 45 minutes. We'll do a little polar alignment. Getting dark out there. You can see clouds are going away, and I think I'm gonna see if I can get lined up. North Star should be right about there. So we can line up the scope and get ready for imaging, and it's cooling down right now. Let's see the temperature. Let's see what's going on here with the camera. Cooling down nicely. You can see we're down to -7. -7 degrees. So we're on our way, and good timing because it's just about darking out, at least around here in the city. You got a city light right there. I'm gonna be putting on a shade right there to block that off. But let's see. Put on my gloves. I like nice rubber gloves so I can grip the knobs right there. And I'll show you a little bit of that. So let's bring up this piece of software we're going to be using. It's called Sharpcap. And let's see here. Boot it up now. Connect the camera. Temporarily connect the guide camera. See, that's the imaging camera. This is the guide camera. We're going to use the guide camera to get polar aligned. Let's see how come. Well, there's the problem, everybody. It's cloudy, right where the North Star is going to be. So let's wait a few minutes. Cool down the camera while the camera's cooling down, just in time, and we'll get all lined up. But we can't get started imaging until those clouds go away and get all lined up with the North Star, the North Celestial Pole. Now, while waiting for the clouds to dissipate, that's okay. I'm going to shoot my flats. They're called flats, and they're calibration frames to compensate for the vignetting on the lens. When we process our images at the end are calibration frames. And so what I'm going to do is, while we're waiting for the clouds to disappear, I'm going to shoot my flats. And what we do is I put a piece of opaque paper, basically sheets of diffusion, in front of the lens, in front of the telescope, at different sizes for different telescopes. So for this lens, it's just a frame of diffusion about that big that I put on top of in front of the lens, and then I clip on this little light, this LED light, and that shines through the diffusion down into the telescope and the imaging camera, and we take a set of what we call flat frames, and then we turn off the light, we put the lens cap on, and we take a set of dark frames. And so those are what we use at the end when we post-process our images from that we're going to take tonight. Here's the piece of diffusion, the frame of diffusion. I'm just using a neutral density filter, sandwiched some pieces of diffusion in between there. And then I set that on top of the telescope. And then I'm going to clip the light, this clip light on top somewhere. And that's going to shine through the diffusion. And we're going to use that to remove the vignetting or any optical artifacts, even dust that collects on the sensor and on the camera. So these are called flat frames. And then I'll take a bunch of those, 15 of those, and then I'll shut the light off, put the lens cap on, and we'll shoot what's called dark frames. So here in my software, it's called NINA, Nighttime Imaging and Astronomy. And that's the name of my, that's the brand of the telescope, and that's the millimeters. It's an Askar 135. So what we're going to do is shoot our flats, and I've got it set up here. It's called a Flat Wizard. Got the light set, got the filter set, got the, let's see, the gain. Make sure, should be 1. Alrighty. So I got it set to take 15 flats and 15 dark flats, and it's going to tell me what to do here. I'm going to hit play. So it's saying my flats are too dim. Brighten the light. Adjust the tolerance. or lengthen the exposure time. So let's see here. I'm going to cancel that. I'm going to brighten the light a little bit here. Oops. You know what I'm going to do? I'm going to actually just get down closer, a little bit closer. I want to get it even, nice and even, so I'm a little closer. Alright, I've got it set. Taking flats, the calibration frames, flat frames there. You can see the various artifacts that will be canceled out. So let's see here, let's take a look. That's the setup right there. Flat frame setup. So in software, when we go to process our frame, it's going to subtract this vignetting out. Going to subtract that out. Each flat frame is taking 14 seconds right there. It's calculated to get the proper exposure. And that filter that I'm using, the Antlia filter, is pretty heavy filter. Exactly, yeah. Like I said, it only lets in a couple of bands of light, a couple of frequencies. The hydrogen alpha, ionized hydrogen alpha, and oxygen 3, ionized oxygen 3. So it's pretty limited, and it dials out all this light pollution right here. That's still cloudy out there. Still cloudy. So hopefully that's what it's all about. This hobby's all about. Gotta roll with it. Flats are done. Now I'm being instructed to cover my telescope and press OK to take dark flats. So look at this little guy. This is the little lens cap for the antenna for that telescope. I got my hobbies confused. All right, so this is the lens cap. I'm gonna take. This is my flats frame. It has that opaque diffusion in it, covering the telescope. This is an actual telescope, everybody. That's a telescope. So I'm going to take my lens cap, screw it in. No light's getting through that. Turn off this light. We finally got a clearing in the sky. I don't know if it's going to be clear for the rest of the night, but it's almost at 9:30 in the evening, and that's the view looking north of the guide camera. I think that's definitely enough to get started with polar aligning, more than enough. So let's see here. We are in the program called Sharpcap, and we're going to pull down polar align. This is pretty cool, actually. All right, so what it's doing, it's identified some stars. These are all stars that it's going to use to align. It's telling me to hit next before rotating the RA axis. I'm going to hit next. Now rotate the RA axis. All right. I don't know if we'll be able to see this at night, but let's see here. I'm going to unpark. I got a good speed there, and you'll be able to hear the telescope skew, so I'm going to rotate the axis now. So you hear it getting up to speed. I'm holding down the trackball here. I don't know if you'll be able to see it. Yeah, I won't be able to see that. But it's rotating to the right now. And you can see stars will be rotating there. You can see the... So let's see. Cooking. There we go. So, I don't know if you can see that. It's rotated now. Looking up at the North Star up there. You can't see it naked eye, but go back to the Sharpcap. Now what's it telling me here? Move this guy out of the way. Hit next before adjusting the alt azimuth. So I'm going to hit next. Not too bad. So that's how far I'm off right there. Show me how far I'm off right there. And I've got to I've got to take the right knob and rotate it just a little bit. What I want to get that, I want to get this number down well below, as close to 0 as possible, definitely under a minute. So let's see what we can do. So I'm going to be tweaking these knobs, the right and left knob and up and down knob, and trying to get that as close as possible. It's pretty cool. As I turn a knob, these things it gets closer. It's like, well, you're driving the scope, you're driving the telescope, and all the while this software is analyzing it. It's getting closer and closer. So let's see how close I can get. So it's without adjusting from the other night. You know, the other night I got it down to well under 20 with 20 seconds. This is 1 minute 44. So if I can get it down to under 30, that'd be great. Let's see how close I can get. I did some knob tweaking, and I got it down to excellent polar alignment right there. And you can see it fluctuating, and that's really just the local seeing conditions, and that's it's the atmosphere, the moisture in the atmosphere, and that's affecting the way that the photons are coming through the atmosphere and hitting my camera. So, but that's well within range for the focal length that I'm photographing at. I don't know if we'll be able to do anything useful tonight, but at least we'll be set up for tomorrow night, and hopefully tomorrow night will be better. But who knows? I think I'll do a little plate solving and check out our target and see if it's worth it to get some imaging. So what we're doing is plate solving right now to find our frame that we selected back there. This is our frame right back there. I'm going to move this out of the way. This process is called plate solving. So our camera's all cooled down and we are locating this frame. This is the actual composition through the telescope, 135 millimeter telescope. It's locating that frame, and you'll see it's actually rotated. This is this section right here. So this is the process called plate solving, and it's taking pictures, successive pictures, and it's locating this frame based on a catalog of stars, and it's ready to go. So it's found this frame, and we're ready to start imaging. So let's see here. Hopefully the skies will stay clear. Let's reconnect the guide camera, because we were using the guide camera in the other piece of software, and now we're going to use it in this software. This is the guiding software called PHD2. Push Here Dummy is what it stands for. So right now it's taking pictures of, let's see, there we go, through the guide scope. And now I'm going to select a star here to lock on. So let's pick this star right here. This is the star it's going to use right here. That's the star it's going to use. It's right there. And that's the star that the mount is going to use and the software is going to use. It's going to lock onto it. I'm going to start guiding on it. Let's see here. So now the mount, this software is talking to the mount that the telescope's sitting on, and it's issuing these commands, and it's making these minute adjustments to the gears. But the goal is to keep this guy, this star, centered, and that's what's going to let us take long exposures of that region in Cygnus. And I'm going to go for 15-minute exposures, and all this, getting everything aligned up with the polar alignment and turning those screws, that's helping that guide number right there be as low as possible, 0.42. So basically that's each axis, each color. That red color is one axis, and the blue color is another axis, and it's making corrections, very slight corrections to each axis to keep that star centered. Man, that's looking really good, actually. So let's go over to the actual imaging software. This is the guiding software, and now we're at the imaging software. That's our frame. And this is our sequence, which is basically a set of commands that it's going to be that we're going to be using tonight. And this is from the other night, so I'm going to reset everything. So this is our target. This is our region. IC 1318. That's the Butterfly Nebula. And let's see, I have it set for 900 seconds. I'm going to take 15-minute exposures, loop those exposures, and till 2 a.m. tonight. So it's guiding right now, and then at 2 a.m. it's going to park the telescope. I got it set to park the telescope right here. It's going to take off the cooler, it's going to warm it back down, stop the guider, and we'll check out to see how things are through the night remotely, and that's what's going to happen at 2 a.m. So let's see. Let's go to this tab, imaging tab. Everything's good to go. We're guiding. See, this piece of software is talking to the other piece of software, and these are the guiding numbers from the other piece of software. You'll see. So that's the same information. That's right here. And so it's guiding, ready to go. I'm going to check one more thing. Check my sequence one more time. All right, good to go. All right, let's do it. So it's literally hit and play right here. Hit play. All right, hit play on our sequence. We started exposing. 7 seconds of 15 minutes to go. All right, we're imaging. So this is going to go till 2 a.m. and we'll see. It's clear right now. I'm hopeful maybe we'll get 4 hours of imaging to add to our about 4 hours of imaging we got the other night. All right, hit play on our sequence. We started exposing. 7 seconds of 15 minutes to go. All right, we're imaging. So this is going to go till 2 a.m. and we'll see. It's clear right now. I'm hopeful maybe we'll get 4 hours of imaging to add to our about 4 hours of imaging we got the other night. Things are looking good outside. Just got the first 15-minute exposure just came in. Let's check it out. I remoted into the laptop from inside, and we're looking at the guiding software right now. Let's see what the first sub looks like. We're monitoring the laptop that's outside. Let's see, it's moving. Making adjustments, minute adjustments. You can see minute adjustments being made to the mount. And let's see what it looks like. There's the first sub. In astrophotography, we call each frame a sub exposure, because all these exposures will be stacked up together, and that's how we process astrophotography pictures. It's a bunch of exposures stacked up in order to get a better signal to noise ratio is what they call it. So you see the Crescent Nebula right there. This is the Butterfly Nebula, and this is all in the Cygnus region, the Swan. See right here, let's see here. It's the last sub. Oh no, that's the first sub, sorry about that. So you see it's counting the stars. number of stars. 1,945 stars. Wow. The software knows. There's the filter. It's negative 10 degrees Celsius. It's using 61% of the power to cool it down. It's a lot of, at least it's not 100%, it's better. 61%, it's not working too hard, not working the camera cooler too hard. But yeah, that's going to go till 2 a.m. And we'll integrate that. So that's why astrophotography is one of the more demanding forms of photography out there. A lot of processes, a lot of got to be a stickler about things, got to be precise. And all the gears got to be working together. And of course, the skies have to cooperate. The skies did clear up tonight. It's 10 o'clock. Finally, they cleared up. And then we'll take all those frames, the calibration frames, all these frames that we're taking tonight and we took a couple of nights ago. We're going to do what's called integrate them all in another piece of software called PixInsight. And then we'll take you through that process until we get a nice finished image of this image of the Cygnus region, all that nice nebulosity. Hit that like and subscribe button. We're never working too hard at Big Kid Working.